Hey, what's up everyone? Today we're diving into some physics MCQs, so grab your notes and let's get started. Question 1. Viscosity of a fluid depends upon A. Mass, B. Density, C. Volume, D. Temperature. Pause to guess the answer. Explanation. The correct answer is temperature. Viscosity refers to how easily a fluid flows, and it changes with temperature. For example, honey flows more easily when heated because its viscosity decreases. Question 2. Drag force exerted by the fluid on a body does not depend upon A. Viscosity of fluid, B. Terminal velocity, C. Shape of a body, D. Volume of fluid. Pause to guess the answer. Explanation. The correct answer is the volume of fluid. Drag force depends on how thick or viscous the fluid is, how fast the object moves, and the shape of the object. The overall volume of the fluid around the object doesn't matter. Question 3. A steel ball of radius r is moving with uniform velocity v in mustard oil. The drag force acting on the ball is F. What would be the drag force on the steel ball of radius 2 times r, moving with uniform velocity 2 times v in mustard oil? A. F. 2 times F. C. 4 times F. D. 8 times F. Pause to calculate your answer. Explanation. The correct answer is 4 times F. The drag force depends on the radius of the ball and its velocity. Doubling the radius and velocity increases the drag force by 4 times, because both radius and velocity multiply the drag force together. Question 4. When two spheres of the same volume but different masses fall through a fluid, then A. Both gain their terminal velocity simultaneously. B. Neither lighter nor heavier body gains its terminal velocity. C. Lighter body gains its terminal velocity earlier. D. Heavier body gains its terminal velocity earlier. Pause to think about terminal velocity. Explanation. The correct answer is that the heavier body gains terminal velocity earlier. Terminal velocity is the point where gravity and drag forces balance out. A heavier object has more gravitational pull, so it reaches that balance quicker. Question 5. Laminar flow usually occurs at speeds A. Low, B. High, C. Very high, D. Sometimes high and sometimes low. Pause and think. Explanation. The correct answer is low. Laminar flow happens when a fluid moves smoothly in parallel layers, which is common at low speeds. At higher speeds, the flow becomes turbulent. Question 6. In an incompressible fluid, which parameter remains constant? A. Pressure, B. Volume, C. Temperature, D. Density. Pause to answer. Explanation. The correct answer is density. An incompressible fluid means that the density of the fluid does not change, no matter how much pressure is applied. Question 7. The equation of continuity is derived from the law of conservation of A. Energy, momentum, C. Mass, D. Force. Pause and guess. Explanation. The correct answer is mass. The equation of continuity ensures that the mass flowing into a system equals the mass flowing out of it, as long as the fluid is incompressible. Question 8. In the equation of continuity, the product of area and velocity is constant. This constant is equal to A. Flow rate, B. Volume of fluid, C. Mass of fluid, D. Density of fluid. Pause to consider your answer. The correct answer is flow rate. The equation of continuity describes how the amount of fluid passing through a tube remains constant over time. Question 9. When the cross-sectional area of a tube is decreased, the speed of fluid through it, A. increases, B. decreases, C. stays the same, D. becomes 0. Pause and think. Explanation. The correct answer is increases. When the area of the tube gets smaller, the fluid must move faster to maintain the same flow rate. Question 10. As water falls and its speed increases, its cross-sectional area, A. increases, B. decreases, C. remains constant, D. becomes 0. Pause to visualize the flow. Explanation. The correct answer is decreases. Faster water flow reduces the width of the stream, similar to how a thin stream of water forms when you pour from a bottle. Question 11. Bernoulli's equation is derived from the principle of conservation of A. Mass, B. Energy, C. Momentum, D. Force. Pause to decide. Explanation. The correct answer is energy. Bernoulli's equation shows how the energy in a fluid system is distributed between pressure, velocity, and height. Question 12. What is the speed of water flowing from a tank with water at a height of 2.5 meters? A. 5 meter per second. B. 6 meter per second. C. 7 meter per second. D. 8 meter per second. Pause to calculate. Explanation. The correct answer is 7 meters per second. The speed can be calculated using Torricelli's theorem, which relates the height of the water to its speed. Question 13. A 2-meter-high tank is full of water. If a hole appears at its middle, the speed of the water flowing out is approximately A. 4.42 meter per second, 5.42 meter per second, C. 6.42 meter per second, D. 7.42 meter per second. Pause to guess. Explanation. The correct answer is 4.42 meters per second. Since the hole is at 1 meter height, we use Torricelli's theorem to calculate the flow speed. Question 14. A Venturi meter is used to measure the A. Density of a fluid, B. Velocity of a fluid, C. Pressure of a fluid, D. Viscosity of a fluid. Pause to guess. Explanation. The correct answer is velocity of a fluid. A Venturi meter measures fluid velocity by observing pressure changes in a constricted section of a pipe. Question 15. When the velocity of a fluid increases, its pressure, A, increases, B, decreases, C, stays the same, D, does not depend on velocity. Pause to think. Explanation. The correct answer is decreases. According to Bernoulli's principle, an increase in velocity results in a drop in pressure. Question 16. Systolic pressure is called A. Low blood pressure, B. High blood pressure, C. Normal pressure, D. Irregular blood pressure. Pause to guess. Explanation. The correct answer is high blood pressure. Systolic pressure refers to the higher pressure when the heart contracts.